Hello everyone. In this session, we will see how to measure attenuation and VSWR at microwave frequencies. We know that attenuation is the ratio of input power by output power measured in decibels. The amount of attenuation can be measured by using two methods. One is power ratio method, another one is RF substitution method. Now we will see how the attenuation is measured using power ratio method. For this one, two different configurations of microwave bench setup is used. In setup 1, there will not be any device whose attenuation is to be measured. Now the microwave source is adjusted to show the deflection in the power meter. In the second setup, yeah, my device whose attenuation is to be measured is inserted between frequency meter and slaughter line section. Now the power in the power meter is measured. Now by taking the ratio of P1 by P2 will give you the amount of attenuation introduced by the device under test. The disadvantage of power ratio method is the output of the circuit is not linear. Results will not be accurate if the attenuation of the network is large and if the input power is low. Now we will see how the attenuation is measured using RF substitution method. In this method also microwave bench setup is used. There are two different configurations are used. In setup 1, a device whose attenuation is measured is connected between frequency meter and slaughter line section. Now the reading shown by power meter is noted down. Let us take it as P1. In the second setup, a network whose attenuation is to be measured is removed, and that place a variable attenuator with the initial zero attenuation is connected. Now the probe of the variable attenuator is slightly adjusted to show the previous power value in the power meter. Now the attenuation shown by the variable attenuator is corresponds to the amount of attenuation introduced by the device under test. Now we will see procedure for measuring VSWR. VSWR is nothing but voltage standing wave ratio. Voltage standing waves are produced only if load and source impedances are not perfectly matched. If load and source impedances are not matched, some part of the incident signal will be reflected by the load, and those signals will combine with the incident signal, and signal with the fixed maxima and minima are produced. These kind of waves are called as standing waves. This is undesirable characteristics of an microwave network. This can be measured with the help of reflection coefficient. VSWR equal to V max by V minimum, which is equal to 1 plus rho by 1 minus rho. Rho stands for reflection coefficient. The value of VSWR may vary from 1 to infinity. The VSWR measurement is classified into two types, low VSWR and high VSWR. If value is less than 10 means that falls under low VSWR category. If the value of VSWR is greater than 10 means that comes under high VSWR category. For measuring the low VSWR, initially we need to take the microwave bench setup. In this microwave bench setup, pad or attenuator is adjusted to show adequate reading in the voltmeter. After that, the probe which is attached with the slaughter line section is moved to get the maximum reading as well as the minimum readings in the voltmeter. Those maximum and minimum readings are noted. Then finding the ratio of maximum voltage by minimum voltage will give you the value of VSWR. Now we will see the procedure for measuring IVSWR. Now for measuring the IVSWR also, the same microwave bench setup is used with the slaughter line section. Now probe of the slaughter line section is moved to get where the point where the power is twice that of minimum power, and again the probe is moved towards right hand side to get the second point where the power is twice that of minimum power. From that we can able to find the D2 minus D1 distance between two power minimum points. After that, lambda c can be calculated by using the formula 2 into A, where A is the broader dimension of the waveguide. Then lambda naught is calculated by using the formula C by F. C is the velocity of light, F is the frequency of the microwave signal. Then by using the formula, lambda g can be calculated. Lambda g equal to lambda naught by root 1 minus lambda naught by lambda c whole square. From that, we can able to get VSWR value. VSWR equal to lambda g by pi into d2 minus d1.